Hey guys. So I decided as we're kind of ramping up our AP review, I decided to just make a video for you guys of just some must know things for the AP test. This is by no means an extensive list of everything you need to know. You have the study guide to guide you through that, but these are just things to remember and are essential as you're doing your review. So, and we're going to kind of go through in the order that we learned it. So first thing is if it says describe or compare the distributions, do SOCs in context. In context means say what you're talking about, like the distribution of test scores or the heights or whatever it is. SOCs, just as a reminder, shape, okay. We basically had skewed left, skewed right, or approximately symmetric. Okay, you don't want to say usually symmetric unless it's perfect, so use that word approximately. Outliers, okay. I doubt you're going to have to use the outlier check. More likely you'll probably just have to glance at a graph that they give you and if there's any points that stand out as outliers. But that's the check to get the fences as a reminder. The center, you use the mean or the median. If the distribution is skewed, you use the median. Okay, and we'll talk about why again in a sec. For measures of spread, we have the range, the IQR, and the standard deviation. Standard deviation goes with the mean. So if you use the mean as a measure of center, you could use the standard deviation as a measure of spread. IQR goes with the median. So if you use the median as a measure of center, use the IQR as a measure of spread. Range you can use anytime. Okay, and then why do we use the median if it's skewed? Well, that's because the median is resistant, which means it's not affected by outliers. So if the distribution is skewed, it doesn't change the median much, but the mean is not. Okay, so that's a must know. You saw that on one of the free responses I gave you. And then another thing that kind of relates to the distributions is if you add or subtract something from all the data values in a data set, it affects the measures of center only, okay, because you're just shifting everything up or down. If you multiply or divide all the data values in a data set by something, this would affect measures of center and spread, okay, because if you're multiplying it by something, it's not going to change them all equally, right? Like the bigger ones are going to get bigger faster. So that's something that they may ask about on the AP test. Remember, this year they're kind of de-emphasizing calculations, it seems to me, and emphasizing concepts. So make sure you have that conceptual understanding. Okay, let's keep going. Next, just talking briefly about linear regression. So just a few refreshers with linear regression. Make sure if you write an equation, you put that little hat over the y, and that means predicted. Make sure you define variables when writing equations. Okay, so what does that mean? You say x is, height, and y hat is predicted weight. Okay, so in addition to writing the equation, define variables. A is the slope. Just a reminder of how you interpret the slope. The slope is for every one increasing x. How does y change? And the y-intercept is when x is 0, what is y? So if you're asked to interpret those, just a reminder. Another thing you should remember is a residual. A residual is the actual minus the predicted. So it's y minus y hat. So just a visual for you to see. So this would be your actual y, where your point actually is, and this is your y hat. So the difference between those is the residual. So it's the vertical distance. It's how far off the point is from the line. The bigger the residual, the further the point is away from the line. The smaller, the closer it is. So if your residual is positive, that means your point's above the line. And if your residual is negative, it means your point is below the line. Okay. All right, then we're going to get into sample and experimental design. So I'm not going to go through every single one of these, but it's just a reminder. Make sure you know the sample and experimental designs. So the sample designs that we talked about are SRS, stratified, cluster, systematic. Okay, you should have those in your notes. Again, I'm not going to go through them all. If you have questions, you can reach out to me. And then experimental designs. The experimental designs we have are matched pairs, completely randomized, and block. Okay, just matched pairs, just as a reminder, that's only used for 2 treatments, and that's where you have 2 groups, both groups get both treatments. just in a different order if it's possible. Block is where you split up by some characteristic and then assign the treatments within the blocks. Again, reference your notes for these. Let me know if you have questions. And then another thing to remember that kind of goes along with linear regression or this stuff, is common response and confounding. So if there's a lurking variable at play, the way the lurking variable interacts determines if it's common response or confounding. The easiest way to remember it is if the x and the y have the lurking variable in common, that's common response. So in common response, the lurking variable affects the x, the explanatory, it affects the y, the response. And because of that, it seems that there's a relationship between x and y when there is really not. Confounding, just think about confounding means like all mixed up. So in confounding, the x affects the y, but the lurking variable also affects the y, so it's confounded because you can't really distinguish which one's having a bigger effect. Okay, probability, everybody's favorite. Okay, and remember, this is not everything you need to know. This is just, I'm trying to do a quick run through. So just one thing to remember that they like to ask about is a conditional probability. So if you see that little line, probability of A, line B, just remember that means given. So that's the probability of A given B. They might ask you a question related to that using a two-way table. So for example here, what's the probability that they like math given they're a girl? So it says given they're a girl, I'm not going to look at the total of the whole table. I'm just going to look at the girl row. Okay. And if I add these two up, 9 plus 9 is 18. So it's going to be out of 18. And then of those girls, how many like math? 9. So it's 9 out of 18, or 1/2. So just remember, if it's a conditional probability, you only look at the row or column that has the condition. Another thing we did with random variables, with probability rather, is random variables. So random variables looked like this. One thing to just mention is if they ever, say, asked you to determine if this is a legitimate distribution, just remember all of the probabilities have to add up to be 1. Okay, and they do here if you add them all up. The mean and expected value, okay, these are on the formula sheet. So there's no need for you to memorize these, but do know how to use them. So remember, another name for the mean is the expected value, because it's what you would expect in the long run. It's the sum of all the data values times their probabilities added up. So just to show you here, you do 1 times 1/6 plus 2 times 1/2 plus 3 times 1/6 plus 4 times 1/6. Okay, so, and then you just add them up. And then the standard deviation, it's the sum of the data values minus the mean squared times the probabilities. Whoops, and then it looks like I forgot. If you want the standard deviation, you have to square root that, okay? Otherwise, it's the variance. So I won't go through the whole formula of that one, but just to show you, like for this one, I would set it up so I'd do 1 minus whatever my mean is. I'm not going to calculate it, squared, times the probability that is 1/6. Plus, then I do 2 minus whatever my mean is squared times the probability of that, which is 1/2, and so on. Okay, so just make sure you know how to use those formulas. Another thing related to random variables is if you're combining two different random variables together and you want to find the mean of the new random variable, you just add the mean separately. If you want to find the standard deviation of combining two random variables together, that's where you use what I call the Pythagorean theorem of AP Stats. So you take remember you have to add variances, not standard deviations. So you take the variance of the ones plus the variance of the other, add them up, and then if you want the standard deviation, you'd have to square root it again. Okay. Another thing related to probability is geometric and binomial distributions. So, and if you watch the video where I went over the free response, you kind of already saw this, so I'll just run through it quickly. But if you remember the acronym BINS, that will help you with the geometric and binomial. So the B stands for binary. There's 2 outcomes. I stands for that the trials are independent. F, I'm going to skip N for a second. S is the success probability is the same for each trial. Okay, so that Those three are true whether it's binomial or geometric. These three conditions have to be met. The n is what changes. So if it's a binomial, you have a fixed number of trials, and you're counting the number of successes within those trials. If it's a geometric, there's not a fixed number of trials. You're going till you get a success. Okay, so I don't know how much they're going to have you actually calculate with these, but it is possible they even say ask a question. How do you know a geometric distribution is appropriate here, or how do you know if it's a binomial or geometric? Okay. So I would just say if you ever see a probability question, you're totally stuck, don't know where to start, see if it meets the BINS criteria. And then just as a reminder, these are given to you on the formula sheet, but just make sure you know how to use them. Okay, I'm not going to go through them because I'm trying to not make this video super, super long. But if you have questions about how to use them, reach out to me. Okay. Make sure too that you've looked at, the formula sheet. If you have a printer, I would say print out a copy so that you have it for the day of the test. You can also access it just digitally online. But so that's that. And then we're going to move on to the last two topics, big topics, which are confidence intervals and tests. Okay, so within here, there's lots of different formulas, lots of different calculations. I gave you guys that inference summary sheet. It's posted in Google Classroom. I would look through that if you're struggling with the formulas and the conditions. That being said, it is possible that they'll have you actually calculate a confidence interval, but more likely than not, my guess is they're going to have you interpret it or understand or maybe check conditions. So make sure you know the conditions. So just remember the interpretation is always, I'm using 95% as an example. Okay, it doesn't have to be 95. We are 95% confident that the true, whether it's a mean or a proportion, or it could be a difference in means or difference in proportions, is between whatever and whatever. Okay, so it's always about the population. So you could even, if it helps, you can write that word population in here, that the true population mean or proportion. That's the goal of a confidence interval, is to estimate something about the population. Another thing to make sure you know is if they ask you, what does it really mean to be 95% confident? And this is a hard one to remember. But if we're 95% confident, it's if samples of the same size were repeatedly taken, 95% of them would contain, 95% of the confidence intervals. Okay, sorry, looks like I wrote that wrong. So if samples of the same size were repeatedly taken, 95% of the confidence intervals made from those samples would contain the population mean. So in other words, if you had all your intervals, 95% of them would contain the population mean or proportion. This is one I know they've liked to ask about in the past. I don't know if they will this year or not. The exam is shorter, but I would say that's one to know. And then going on to tests, and again, same thing for tests. All the formulas, conditions, I would look at that study sheet. I'm more focusing on concepts right now. So when you're doing a test, make sure you know how to write the ho and the ha. Because that's another thing I've seen on some of these practice tests coming out. Rather than like doing the whole test, they're just asking you to write the ho and the ha and then interpret the p-value. Okay. So p-value. P-value, if they ask you like what it means, it's the probability of getting what you got in your sample or something more extreme, assuming the ho is true. So it's really a conditional probability. So assuming the ho or the null is true, it's the probability of getting what I got, in whatever value you get in your sample, or something more extreme. And also know how, if they give you a p-value, how to make the right conclusion and how to word your conclusions. So if your p is less than or equal to your alpha, they don't tell you one, remember you use 0.05. You reject the ho and you have evidence towards the ha. Okay, it's always a two-part conclusion. If your p is too big, it's bigger than your alpha, then you fail to reject the ho and you have no evidence towards the ha. Again, a two-part conclusion. Other concept to know with tests is type 1 and type 2 error. Type 1 error is if the ho is true, but you reject it. And a type 2 error is kind of the opposite. If the hoe is false, but you keep it, you fail to reject it. So it's possible too that they might have you write a hoe and a ha and say, explain what a type 1 error is for this problem, or a type 2 error. Okay, so make sure you're able to word it correctly depending on what your hoe is. And then lastly, power of a test. Okay, they sometimes like to ask about this. The power of a test is the ability to correctly reject the null or the hoe when it is false. Okay, because that's usually how you design a test. Usually you design a test where the hoe is what you're kind of assuming is true, and the alternative is what you think is true or trying to prove. Okay, so if you're able to correctly reject the hoe when it's false, you're not going to have to calculate power, but you should know you can increase the power of a test by increasing the sample size, because that makes you more likely to make the correct decision, or increasing alpha. Okay. Why? Because it gives you more room to reject. Remember, you reject if your p is less than or equal to alpha. So if your alpha is bigger, you're more likely to reject. Okay, so I know that was a lot, but that was just a quick run through. Again, that is not everything you need to know for the exam. Okay, those are just my important must-know things. Okay, additionally, make sure that you've gone on the exam demo. Make sure you're completing the practice tests that I am posting. Make sure you're reaching out to me with any questions that you may have. I also suggested that in addition to the formula sheet, you make your own reference or cheat sheet that you can access during the exam, since they're assuming it's open book, open note. Okay, guys, that's all for now. Please come to office hours or reach out to me if you have any questions or concerns, but we're in the home stretch. All right, talk to you guys later.